multiplying fractions. Today, we are going to continue our quest on multiplying fractions. This time, we're going to be multiplying mixed numbers by whole numbers. Mixed numbers by whole numbers. So you're going to need your packet, a couple colors again, reminders that you can pause or rewind if you are starting to get behind. Also, should you have any questions, please write them on the front cover of your packet so that we can go over them in class. Your homework after watching this video is to figure out the shortcut and complete the You Try problems. And we'll be going over both in class. You are responsible for both things. Also, your packet should look like mine. It should be completely filled out. All right, so multiplying mixed numbers by a whole number. A reminder that this problem, it is multiplication, so you may see it as 5.5 times 3, or you could see this problem as 3 times 5 1/2. What does it mean? Well, it could be that there are 3 people. That each are going to get 5.5 cookies. We want to know how many cookies do we need to have available. So we could write this as repeated addition because that's what multiplication is. I can say 5.5 plus 5.5 plus 5.5. When I add those together, I can say 5, 10, 15. Then half and half make a whole, that's 16, plus another half gives me 16.5. Just as before, I want to confirm my answer. Oh, and I need to say that this is 16.5 cookies. I want to make sure that I label what my answers mean. And this is going to be person 1, person 2, and person 3. So as with before, we want to show how to get that answer in multiple methods. So let's start out by drawing a picture. Since our fraction has a denominator of 2, we know that 2 make a whole. So I'm going to draw person 1. These are going to be kind of bar cookies, or maybe think of them as candy bars. So person 1 is going to have 1, 2, 3, 4, 5, and then 1 box makes a half. Person 2, 1, 2, 3, 4, 5, and 1 box makes a half. Person 3, 1, 2, 3, 4, 5, and 1 makes a half. How many halves are there for each person? Well, this is a half, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 half pieces of cookie for each person. If we took each of these cookies and broke them in half, we would have 11 half pieces for person 1, 11 half pieces for person 2, and 11 half pieces for person 3. So how many halves do we have? Well, we have 33 halves. 11 plus 11 plus 11 gives me 33, plus and my denominator stays the same. So I have 33 half pieces of cookie if we had broken them all apart. Well, we're not necessarily going to do that because if we break the cookie apart, then there's crumbs that come out, and that's less cookie that I'm going to end up eating because of those crumbs. And I want to have every delicious little bit. So we're going to keep them as wholes. So we want to know how many whole cookies are we making. Because when I bake cookies, I'm not going to bake 33 half cookies. That doesn't make any sense. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. These two make a whole 16 and a half. So I need 16 and a half cookies. In reality, how many cookies am I going to bake? Well, I'm going to bake 17. Although most recipes will do 18 or 24, so I probably end up making that and just eating the rest myself after I've given them to these 3 people. So next we're going to look at how can we represent this on a number line. So I know that given the 2 answers I've come up with so far, we decided that this over here, if I divide by 2, that I get 16 and a half cookies. All right, so basically based on what I've come up with so far, I probably need to put 0 to 20 or so on my number line. Again, I like to have a little extra just in case I've made a mistake. It's certainly possible that I've done this 2 ways and somehow I made a mistake. So I'm going to start 0 and I'm going to count up to 20. Okay, so now I need to figure out how am I going to count on the number line. There's a couple different strategies that I could use. So I'm going to grab a couple colors here to show this in more than one way. So I could count by 5s. I think that's the first way. And this is, for this particular problem, this is my more preferred way, is I'm going to say 0 to 5, then 5 to 10, 10 to 15. So I'm taking care of my whole number 5, and then I'm going to do 3 half hops. So each of these had a value of 5, and then I'm going to do 1, 2, 3. Half, half, half. So I have 3 half hops. So that's one way I could have done this. Another way I could show this is I could just go straight to 5 and a half and do it exactly as the problem is written here. So go from 0 to 5 and a half. This one I have to do a little bit more counting. I can't just count by 5s. So I know a half takes me to 6, and then 6 plus 5 is 11. So my next stop is going to be 11. Now 11 plus 5 is going to give me 16, and then 16 plus a half is 16 and a half. So in my opinion, this way takes a little bit more skill, but either way is fine. Both ways will work, as you can see. So again, this is person 1, person 2, and person 3. On my top section, this is going to be person 1, person 2, person 3, and then here I have to repeat person 1, 2, and 3 again for each of their half pieces of cookie. So I've confirmed my answer in 3 ways, and really 4 because I did the number line 2 different ways, that I'm going to need 16 and a half cookies to feed these 3 people. Is there a shortcut? There absolutely is a shortcut. See if you can figure it out. There's a couple different shortcuts that will work for this particular problem. I'll give you a clue that part of it might be, there might be some information in here that could be used towards the shortcut. Are you with me? Does your paper look like mine? If it does, then go ahead and move on with me. If your paper doesn't look like mine and doesn't have all the detail that I have on my paper, go ahead and pause and finish filling in your paper. Please don't go on until your paper looks like my paper. So our next problem, same topic. 1 3/4 times 4. So what does this mean? Well, it means that I'm going to do 1 3/4 plus 1 3/4 plus 1 3/4 plus 1 3/4. I could also rewrite this as 4 times 1 3/4. That would be acceptable as well. The fourth pieces here also make a really nice transition to decimals. This is a great problem that if you wanted to rewrite it as decimals, that would work as well. But our focus here is being able to use fractions, so we'll continue with fractions. But do know that you have that option should you want to change to decimals, if that is something that is more familiar and more comfortable to you. Okay, so I want to draw 1 3/4. So that means I'm gonna, and I know that 4 make a hole. So I'm gonna draw one hole, and I'm gonna draw a second hole. Both of them have 4 pieces. I'm gonna color this in as 1, and then I'm gonna color in 3 out of the 4 on the second one. Okay? I'm gonna do this 3 more times. So now what do I have? Well, each of these, how many fourths do I have in each set? I have 1, 2, 3, 4, 5, 6, 7 fourths. I have 7 fourths 4 times. Could I rewrite this? Maybe combine some of these? Sure. I could take one of these, so this one, and maybe I'm going to take this fourth piece and fill in that one, make it a complete one. The second fourth piece, fill it in here to make a complete one. And this last fourth piece, fill it in there to make a complete one. So what is it that I end up with? Well, let's see. I have my original 4 hole. I have my original 4 hole, and then I'm taking one and filling it in there, so that makes another hole. The second one from here, I'm filling in there, so that makes another hole. And I'm taking this third one, filling it in there, which makes another hole. So I'm going to go ahead and color those in. And it appears as if I have 1, 2, 3, 4, 5, 6, 7. I have 7 hole in this problem. So 7 fourths times 4 gives me 7 whole. Let's take a look at it on a number line. Now, for this particular problem, because I'm going all the way up to 7 whole and I'm using fourth pieces, I don't have a lot of room on the number line, surprisingly. So I think that I'm going to count by 2 fourths. Normally I like to count by 1 fourths, but due to the amount of room, actually, you know what? We'll still count by 3. We'll still do the whole thing. We're just gonna have to extend our line down here a little bit because they're not all gonna fit. That's okay. So I start with 0, I'm going to count all the way up in fourths till I get to 32 fourths. 32 fourths. You're going to have to extend your line down here. Just follow along with me as I put my numbers on the number line. I am going to continue writing them as improper fractions, but I'm also going to put in my whole numbers as benchmarks to myself so that I have a frame of reference. As you can see here, we run out of room. So I'm going to continue my number line down here. Not ideal, but sometimes it happens. I'm going to try and line up my lines so that everything is being spaced out about the same amount. I'm going to take this 26 fourths and I'm going to write 27 fourths here so that in theory I could just cut this piece out and attach it along the end to continue my number line. Okay, finally have all my numbers done. I can again do this problem in two ways. I could do my whole 1 3/4, 1 3/4, 1 3/4, or I can do one whole, one whole, one whole, one whole, and then do my 3/4 hops. So I think I'm going to start out with doing the 1 wholes and then the 3/4 at the end, and then we'll go and do the other one. Because I can see that there's going to be 4 1 wholes. So 1, 2, 3, 4. So that each have a value of 1. Now I need to do my 3/4. So I'm going to count 3 of these instead of 4. It was really nice and easy because I was able to just count by ones. So now I can do 3/4. So 1, 2, 3. That's 3/4. And then I can do 1, 2, 3 again. And that's 3/4. 1, 2, 3 again. That's 3/4. And then here it's a little tricky because my number line got messed up. But it's going to end right here. Because I have 1, 2, 3. There's my 3/4 continued there. All right, so I see that I again end at 7. Let's try it one more way and do 1 3/4 4 times. So here's 0. The first one's easiest. 1 and 1, 2, 3/4. Excuse me. All right, so that's 1 3/4. Then I need to do 1 3/4 again. So I think I'm going to do 4 whole. 1, 2, 3, 4, or 4/4, excuse me. And then do my 3/4. 1, 2, 3. I'm going to end at 14. Well, that's interesting. I went from 7 to 14 for 1 3/4. Well, that makes sense because up here I determined that there were 7/4. So it looks like down here, if I'm counting by 1 3/4, I'm really counting by 7/4. So I should be able to look at just multiples of 7. Well, let's check and see if this continues to work. 1, 2, 3, 4, 5, 6, 7. So 14, 1/4, 2/4, 3/4, 4/4. So that's my 1 whole. 1, 2, 3. That seems to work again. And then I again want to do 7 more. 1, 2, 3, 4, 5, 6, 7. So I kind of go off my page and on again, and I get 1 3/4. So I again end at 28/4, which is 7 whole. And I can confirm that up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. 28/4 or 7 whole when I do 1 3/4 times 7. If you're more comfortable with decimals, feel free to confirm your answer in yet another way and do this problem as decimals. If we look back at this one here, I can count this up and go 1, 2, 3, 4, and then 3, 6, 9, 12. And I get 4 whole and 12/4. Well, we know that we can't keep an answer like that, but 12/4 is the same as 3. So I get 4 plus 3, which gives us 7 whole. All right, did that work for you? Are you with me? If you're not, go ahead and press pause and make sure that your paper gets completely filled out like mine. Do you need to listen to the explanation again? Is there some piece of it that you missed because you were writing stuff down? Go ahead and rewind. Listen to the explanation again. All right, it's your turn. You're going to do, not 1 3/4 times 4. You are going to do, sorry, wrong page. You are going to do 2 3/5 times 5. 2 3/5 times 5. So go ahead and try that now. Figure out what a shortcut is. Figure out a shortcut for the previous 2 problems. Go ahead and do that now. And remember, pause and rewind if you need to. Write any questions that you may have on the front cover of your packet. Figure out the shortcut for each problem. Figure out the shortcut for each problem and complete the You Try problems. We will discuss all of this in class.